Alright, section 2 is going to be about solving quadratics or quadratic functions. And how we're going to do this is by graphing, by using the square root properties, or by factoring. Now, a quadratic equation is any equation that we can put into the form ax squared plus bx plus c equals 0. So notice there is a variable squared here. We call it x squared. There's a variable alone, just the x. And then there's a term that's just the constant c. The variable squared has an a in front of it, so it's some number times x squared, some number times x, and then just some number alone. These coefficients are a, b, and c, and it's important to identify what each of those are when you are graphing, factoring, or using the square root property. So those are just kind of what we're looking for with quadratics. So let's look at how to solve these by graphing. If we are looking at the graph of y equals x squared. Now this is going to be kind of your basic quadratic function. This is going to be the basic quadratic graph. Now we always look at if it was y equals ax squared plus bx plus c and identify each of those coefficients, a, b, and c. In this case, our a is 1 because it's just 1x squared. Our b is 0. There is no x term. Our c is 0. There is no constant term. Now all of these will have a vertex, kind of a corner point, that you can find by plugging in negative b divided by 2a. So in this case, our b is 0, so we'd have negative 0 over 2 times a is 1. So negative 0 is just 0 divided by 2 times 1 is 2, which means we would have a vertex at 0. So when we're plugging in values into our table to find some points, the middle point of our x values is going to be 0. So for x values, I put our middle at 0, and then we just do some numbers around it. So going downwards, negative 1, negative 2, negative 3. Going upwards, 1, 2, and 3. Now we just take those values and we plug them into our equation. Take x, square it, and that's y. So negative 3 squared becomes 9. Negative 2 squared becomes 4. Oops, that's going away. We'll just take that out of the way. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. You'll notice that these basically are a mirror of each other. This is our middle point at the vertex. 1, 1, 4, 4, 9, 9. These will mirror each other. So we plot our points then. 0, 0 is our vertex. It's that corner point. We have negative 1, 1. We have positive 1, 1. Here and here. We have negative 2, 4. That's up here. We have positive 2, 4. That's up here. Negative 3, 9 goes way off the chart. That would be somewhere way up here. Positive 3, 9 would be way up here as well. So these would be our plotted points. Now we would just connect them. And it would draw kind of a U shape. It's called a parabola. Again, that corner point at the bottom. This is called a vertex. This is where everything else stems off of, and we can find the x value of the vertex by using negative b over 2a. So all of these x values, if you were to take any x value on this line and square it, it will land on this parabola. Let's say we wanted to graph y equals negative 3x squared. Basically, this is the exact same graph as the last one, only we're multiplying everything by negative 3. Our a value is negative 3, our b value is still 0, our c value is still 0. Plug things in for negative b over 2a. Well, b is still 0, so if we were to plug in 0 into the top here, 0 divided by anything will just become 0. So all of our x values that we're going to use in our table should be the same. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. When we plug those in, negative 3 squared makes 9. Then times negative 3 makes negative 27. Same thing when we go through that process with the rest of them. We'll get negative 12, negative 3, 0, negative 3, negative 12, and negative 27. So let's plot out these points again. vertex at 0, 0. First point, if we go positive 1, we'd go down 3. If we go negative 1, we would go down 3. If we go positive 2, we'd be at down 12. If we were at negative 2, we'd be at down 12. Negative 3 and positive 3 are both at negative 27, which is way off of our chart. So we just simply connect these points then. That's one side of our parabola. And that's the other one. So this one is pointing downwards, and it looks like it's much, much steeper. It's kind of a thinner, skinnier U shape. But it still has this point, that's the vertex, and it still kind of continues to swoop as it goes. All right, now we've got y equals 2x squared minus 8x plus 7. Now we have an a, b, and c value to look at, 2, negative 8, and 7. So when we're looking for our vertex, we do negative b on top. Well, negative 8 would just be a positive 8 divided by 2 times our a is 2. So 2 times 2. That means we're looking at 8 over 4. 8 divided by 4 is just 2. So for our table, 2 will be our center point. This is going to be our vertex. And we have all the numbers that are around it. So going smaller, 1, 0, negative 1. Going bigger, 3, 4, and 5. Now that we have our numbers for our table, we just plug them in. So plug negative 1 in for x here. So we're doing negative 1 squared becomes 1. Multiply that by 2, so that becomes 2, minus 8 times negative 1 is negative 8. So if we're minusing a negative 8, that's like we're adding 8. So 2 add 8 is 10, add 7 makes 17. Now you should be able to plug this into your calculators, and it'll solve it out for you. Make sure that you put parentheses around this x squared thing so it knows to do the x value, square it, then multiply it by 2. Don't try to multiply by 2 first. So if you plug it in correctly, these are the values you should get. 17, 7, 1, negative 1, 1, 7, 17. Again, these ones should mirror these ones. If we were to plot these points then, we'll go to our vertex is at 2, negative 1. Here's that corner piece. 1 bigger 3 would be up at 1. And negative or positive 1 would be up at positive 1. 4 would be over here at 7. 4, 7. 0 would be up at 7. Now, unfortunately, from here, negative 1 goes to 17, and so does 5. So those go off the chart. So we can't fit it in. So as we connect these values, oops, missed it a little bit there. This is going to be our parabola. Look, something like that. So this is our parabola for the ax squared plus bx plus c. Now that we have all of our graphs, so this one, and this one, let's discuss how to solve them. Let's say it was no longer y, we called it 0. When we're solving, we're calling our y value 0. This means we are on this x-axis, and we want to find the spots where our parabolas cross that. Well, here it only happens once. It's at 0, 0. So we would say that the x value at this one, x equals 0, that would be our solution to this quadratic equation. Let's look at the next one. Again, we want on this x-axis, where do we cross that line? Again, this one only happens once. It's at where x equals 0. So this would be solving the quadratic functions by graphing. On this one, it crosses twice on this x-axis, once here and once here. Now it's kind of hard to see exactly what those are, but we can say that one of them, actually I'm going to give us a little more space for that. One of them is going to be in between 1 and 2. So 1 less than x less than 2. So x is in between 1 and 2. The other spot that works is x is in between 2 and 3. So this would be our solution. X is in one case between 1 and 2, in one case in between 2 and 3. That would be the solution for this parabola. Now let's say we had a parabola that crossed exactly at 5 and exactly at 7. We would just use those as our values. We'd say x equals 5 and x equals 7. Those would be our solutions or our values for that. So that would be how to solve quadratics with graphing. Let's move on to factoring and using our zero product property. Now for a review, if you have 8 times 0, what would that become? Well, it should become 0. If you have a, so any number times 0, what would it become? Well, that would also become 0. If you have 7 times something equaling 0, what would this something have to be? Well, it has to be 0. Okay, this is part of our zero product property. If two numbers are being multiplied, a times b equals 0, then either a has to be 0 or b has to be 0. Pretty straightforward. So the steps for factoring and using the zero product property, we make sure we get it into the regular quadratic form, ax squared plus bx plus c equals 0. We factor into two quantities using our AC method. We set each quantity equal to 0. So one factor equals 0, another factor equals 0, and then we solve each mini problem for the answer. So let's see how this looks. If we have x squared minus 5x plus 6 equals 0, so this is already set in the correct form. Now we can go ahead and just start factoring. Our a value is 1, so 1x squared. Our c value is 6, so 1 times 6 is 6. We want the factors of 6, and I'll write this on the side. That would add up to negative 5. So since this value is positive, this value is negative, we need negative factors. So like negative 1, negative 6. These would multiply up to positive 6, but these don't add up to negative 5, they add up to negative 7. So we need a different set of factors, like negative 2 and negative 3. These will multiply to 6 and add to negative 5. So these are the two factors we want. So we'll break down our equation into x squared minus 2x minus 3x plus 6. All we did here was take this, negative 5x, and broke it into two pieces, negative 2x minus 3x. These two would add up or combine back to this one. So these equations essentially mean the same exact thing. Now that we've broken this equation into four pieces, we can factor it by grouping. Here's one group. Here's one group. So out of this group, what can we take out? We can take out the x. That would leave x times x minus 2. Out of these two, what can we take out? We can take out a negative 3, and it would leave x plus or x minus 2. Because negative 3 times negative 2 is a positive 6. Now from here, we have x minus 2 in both cases in our parentheses, so that's going to be one of our factors. The other one is this x and this minus 3. Everything is still set equal to 0. So right now, what is our equation saying? It's saying this number, this factor, x minus 2, whatever this comes out to be. If we were to plug in any value for x, this would come out to one number multiplied by this number over here. Again, whatever x value is minus 3. So we have to think of each of these. What if they were set equal to 0? So like, what if we had x minus 2 equals 0? What if we had x minus 3 equals 0? If that was true, what would x equal in this case? Well, we'd add 2 to both sides, and we'd find that x equals 2. What if this was true? X minus 3 equals 0. We'd add 3 to each side, and we'd find that x could be 3. So these two numbers, 2 or 3, are going to be the solutions for this quadratic equation. Either it's 2 or it's 3. Let's try another one. Here we have p instead of x, so p squared plus p minus 52 equals 4. Now this is not in our quadratic form yet. We need to subtract 4 from both sides to make sure we have everything equal to 0. This will leave us with p squared plus 1p minus 56 equals 0. Now when we do the AC method, 1p squared times negative 56 is going to be negative 56. I'll show that over here. We could write out all the factors, but we just need the ones that would add up to 1. If this is negative, we need 1 to be negative, so negative 7, and 1 to be positive. That'll be 8. Negative 7 times positive 8 is negative 56. Those two added together are positive 1. So when we break this apart, this positive 1p becomes negative 7p plus 8p. Now we can go back and factor by grouping this group and this group. What can we take out of the first group? The p value, and it leaves p minus 7. Out of the second group, we can take out 8, and it leaves p minus 7. So p minus 7 now multiplied by p plus 8, right here, equals 0. What values of p would make this true? We're trying to make this 0, so p could be 7. We're trying to make this 0, so p could be negative 8. So these would be our solutions then to the quadratic equation. In this example, we not only have things not set equal to 0, but we also have bigger values of coefficients. So like a is bigger than 1 in this case. So first let's set everything equal to 0 by subtracting 24k from both sides. So we now have 12k squared minus 24k minus 15 equals 0. Now whenever we're factoring, we always first look for a greatest common factor. So 12, negative 24, negative 15, we can take 3 out of each one of those. 3 comes to the outside, and we're left with 4k squared minus 8k minus 5. Now these numbers are a lot smaller and easier to work with. When we do AC, we do 4 times 5, or negative 5, and we would get negative 20. It's going to be a lot easier to use than 12 and 15. So 4 and 5 make 20. I guess with this negative, it's a negative 20. We need the factors of negative 20 that would add up to a negative 8. That's going to be positive 2 and negative 10. Those will multiply to negative 20, add to negative 8. So this would be our equation then. From here, factor and factor, just those two groups. Notice that this 3 stays on the outside because it's still saying 3 is being multiplied by all of this. 3 is multiplied by all of this. 3 is multiplied by all of this. The first group we took 2k out of, and we got 2k plus 1. The second group we took negative 5 out of, and got 2k plus 1. So our factors are going to be 2k plus 1 over here. And we also have 2k and minus 5 right here. So in a sense, we have 3 different factors. 3 numbers are being multiplied to make 0. 3 times this number, 2k plus 1, times this number, 2k minus 5. How would we get 3 to equal 0? Well, that'll never happen. So we don't have to use that as one of our answers. How would we get 2k plus 1 equal to 0? Well, if we set it up as 2k plus 1 equals 0, we'd subtract 1 from both sides and get 2k equals negative 1, and then we divide both sides by 2 to get k equals negative 1/2. So negative 1/2 is going to be the first one of our solutions. We would go through the same process with 2k minus 5 equals 0. We would add 5 to both sides and then divide by 2 to get that k could be 5/2. So our solutions are negative 1/2 or 5/2. There we go. Here we've got another example then. Again, we've got a constant and an x term on this side, a constant and an x squared term on this side. Let's put everything on one side and set it equal to 0. So we're going to add 8x squared, add 3, and we get this. 8x squared plus 13x plus 5 equals 0. 8 times 5 is 40. write that off on the side. What are the factors of 40 that would add to 13? Well, that's 8 and 5 again, just these two. So I'm going to break it down into 8x squared plus 8x plus 5x plus 5. Factor by grouping, take the 8x out of these two, take the 5 out of these two. We're left with x plus 1 in both cases. 10 times 8x and times 5. So our factors are x plus 1 and 8x plus 5 equals 0. So our solutions, for this one it would be -1. For this one it would be -5/8. So these would be our two solutions for this quadratic formula. We'll do our square root properties in the next video.